Good day, students. So on this clip, we're going to be going over 5 examples on how to find the inverse of linear and radical functions, okay? So let's go ahead and write down the instruction for the notes. So we're going to find the inverse of the following, okay? Find the inverse of the following. All right, so the first question we're going to look at is the function f of n equals negative 4n minus 20 over 9, okay? So first thing we're going to do is we're going to rewrite this, and then we'll switch and solve, okay? So first thing we're going to do is rewrite. I want to rewrite it using one variable on both sides, okay? So instead of f of n, I can just write y equals negative 4n minus 20 over n, okay? Now after rewriting f of n as y, I'm now going to switch. I'm going to switch my variables. Okay, I'm going to switch y and n. I'm going to switch them, okay? So anyway you have y, you change it to an n. Anyway you have n, you change it to a y, all right? Because my input is n and my output is y, so I'm going to switch them. So this becomes n equals negative 4y minus 20 over 9, okay? After writing and switching, the last step is just to solve. Solve for y. Alright, whatever y is, that will be the inverse of f of n. Okay, so let's go ahead and do that. To do that, this is a 3-step process. We're going to get rid of 9 by multiplying, get rid of 20 by adding, and then get rid of negative 4 by dividing. Okay, so let's start out with the 9 first. So since we have divided by 9, we multiply by the reciprocal. I'll multiply both sides by 9. 9 goes here 1, 9 goes here 1. So you're going to have 9n equals negative 4y minus 20. And then proceed to add 20 to both sides. Add 20, remember the goal is to get y by itself, okay? So you're going to have 9n plus 20 equals negative 4y. Alright, so to finish this up, you just simply divide both sides by negative 4. And then your inverse, y, is going to be 9n plus 20 over negative 4. And then you can rewrite as f to the negative 1 of n equals 9n plus 20 over negative 4. Okay? So there you have it. Alright, let's move ahead to the second question. Problem number 2. We're going to be looking for the inverse of the function g of x equals x to the third minus 2. So first thing we're going to do is we're going to rewrite it in this case. Since we have f of g of notation, I'm going to replace my g of x with y equals x to the third minus 2. Now after rewriting, I'm going to switch, okay? I'm going to make a switch. My y's will become x's and my x's will become y's. Alright, so let's go ahead and make the switch. We're going to have x instead of y equals y to the third instead of x to the third minus 2. Alright? After your right switch, now you're going to solve for y. Okay? This is a 2-step process. You're just going to add 2 to both sides and take the cube roots to get rid of this cube right here. Okay? So let's do it. So add 2 to both sides. That yields x plus 2 equals y to the third. And let's use the reflexive property of equality to rewrite this as y to the third equals x plus 2. Now the opposite of cube is cube root, or the third power. So let's just take the cube root of both sides. So the cube root of y to the third and the cube root of x plus 2. Okay? On the left side, since cube root and cube are inverses, this cancels with that. So we're going to be left with y equals the cube root of x plus 2. Okay? And then this is the inverse. We can write this as, what was the original notation? G of x. So it's going to be g to the negative 1 of x equals the cube root of the quantity x plus 2. And there goes your inverse. Alright, let's go ahead and move on to question number 3. For question 3, we want to find the inverse of the function f of x equals the fifth root of x minus 1. Okay? So first thing we're going to do is we're going to rewrite using y. So to rewrite this, we're going to have y equals the fifth root of x minus 1. Okay? Now after rewriting it, we're going to make a switch. We're going to switch the input with the output and the output with the input. So y becomes x and x becomes y. So now it's going to become x equals the fifth root of y minus 1. Alright, now we're going to get y by itself. To get y by itself, we add 1 to both sides. That yields x plus 1 equals the fifth root of y. Now, we want to get rid of the fifth root. The opposite of the fifth root is the fifth power. So, to accomplish that, we just raise both sides to the fifth power. Raise this to the fifth power. On the right side, the 5 and the root 5 cancel out because they're inverses. So, we're going to have y equals the quantity x plus 1 raised to the fifth power. And there's your inverse. So, after the negative 1 of x equals x plus 1 to the fifth. Alright, so that's the inverse. Alright, let's move on to question number 4. For question 4, we have the function f of x equals negative 2 times the quantity x plus 2 to the fifth. First thing we're going to do in this case is we are going to rewrite the function using y. Okay, so we're going to have y equals negative 2 times x plus 2 to the fifth. Okay, after rewriting, we're going to do the switch. Since we're looking for the inverse, the input becomes the output and the output becomes the input. So x will get switched for y. So let's make the switch. So we can have x equals negative 2 times y plus 2 to the fifth. Okay? Now to isolate y, which is the next step, solve for y. To do this, it's going to involve, it's a three-step process. Get rid of negative 2 by dividing by negative 2. Get rid of the fifth power by taking the fifth root. And then we subtract 2 to get y isolated. Okay? So let's go ahead and do it. So the first thing to do is to get rid of negative 2, which is to divide both sides by negative 2. So that yields negative x over 2 equals y plus 5 to the fifth. Now the opposite of power is root, so to get rid of this fifth power, we'll take the fifth root of both sides. Okay? On the right side, the root and the power are inverses, so they cancel each other out. So let's use the reflexive property of equality. We're going to switch it around. We have y plus 5 equals the fifth root of negative x plus 2. Alright, finally, to get y isolated, we'll get rid of the 5 by subtracting 5 for both sides. So our final answer y is going to be the fifth root of negative x plus 2 minus 5. Alright, and then let's rewrite it using the appropriate symbol. So since we start with f of x, the inverse will be f to the negative 1 of x equals the fifth root of negative x over 2 minus 5. Alright, so there goes your inverse. Now last but not the least, we're going to find the inverse of the function number 5. G of x equals the fifth root of x plus 3 over 2. Alright, so step number 1, we're going to rewrite. Okay, rewrite the function notation g of x using y. So if we rewrite it, we're going to have y equals the fifth root of x plus 3 over 2. Okay, Now to find the inverse, we have to do a switch. Okay, we have to switch. What are we switching? We're going to switch the y's for the x's and x's for the y's, alright? So to accomplish that, we're going to have x equals the fifth root of y plus 3 over 2. Now to get y isolated, this is going to be a three-step process. We're going to get rid of the fifth root using the power. Fifth power, get rid of the denominator by multiplying both sides by 2. And then get rid of the 3 by subtracting 3 from both sides, okay? So let's go ahead and do the three-step process one by one. So let's get rid of the power first. The root first, sorry, by using the inverse, which is the power. So to get rid of the fifth root, you raise both sides to the fifth power, since root is the inverse and our opposite of power, okay? So this fifth power cancels out with the fifth root here. Let's use the reflexive property of equality to write it as y plus 3 over 2 equals x to the fifth power. Now to get rid of the denominator here, we'll use the inverse of division, dividing by 2, which is multiply both sides by 2. So these two and these two divide out. So you're going to be left with y plus 3 equals 2x to the fifth. To finish this off, simply subtract 3 from both sides. And then you're going to have y equals 2x to the fifth minus 3. So this is your inverse. So you rewrite it. Let's use the original notation. D to the negative 1 of x equals 2x to the fifth minus 3. Minus 3, okay? So there goes your final answer. So thanks so much for taking the time to watch this video. Feel free to subscribe just by clicking up here. More videos can be found on mathexpert.com. Thanks again and have a wonderful day.